Very good morning once again, dear students. Welcome back. Today I'll be continuing the class for class 7 ABC, and the subject I'm doing right now is geography. We had done the previous lessons in the chapter atmospheric pressure. I had taught you in the last class the different types of winds. For instance, what are the permanent winds? What are the periodic winds? See, I told you what are the permanent winds. For instance, the winds that blow in the same direction throughout the year are called as the permanent winds. And I even showed you the diagram of that. Like the examples of permanent winds we have is the trade winds, the westerlies, and the easterlies. See, northeasterlies. These are the different types of winds that blow, isn't it? Polar winds. See, the trade winds. Then we had the westerlies and the polar winds, which are the permanent winds which blow in the same direction throughout the year. Then we came to the periodic winds. What are the different types of periodic winds? Like we saw the periodic winds like the land and sea breeze. Then we also saw the monsoon winds. Then I even told you what are winds. Winds are the horizontal movement of air from one place to another, normally from high pressure to a low pressure. Then I showed you different types of instruments that measure wind directions. Like for instance, wind direction is measured by an instrument called the wind vane. Now how is a wind vane? It's a long sea. And here we have north, south, east and west. And then we could have a rotation on top, further on top. Okay, I'll just, for your convenience, here. North, south, east and west. And then on top here we have an arrow which rotates. See, this is a wind vane. Now what happens is when the wind blows, the wind, suppose it blows this way. When the wind blows, the tail of this wind vane is bigger than the head. See, we can see the tail. It's much bigger than the head. So therefore, more pressure is applied to this tail. And when more pressure is applied to this tail, what happens is this will turn this way. And therefore, it will turn towards me, which indicates that the wind is blowing this way. So whichever side the head or the arrow faces, it is from there that the wind is blowing. That is how we measure the direction of the wind with an instrument called the wind vane. So once again, I repeat, when the wind blows, what happens is the tail of this wind vane is more, the surface is more compared to the head. So more pressure is applied here. When more pressure is applied here, what happens is it will turn this way. The head will turn towards me, which indicates that the wind is blowing from my side. So therefore, to know the direction of the wind from where it's blowing, we'll always have to use an instrument called the wind vane. And from where do we know the wind blows? We have to see where it is pointing. If it is pointing towards the north, it will indicate that the wind is blowing from the northern side. If the pointer turns towards east, it is from the eastern side that the wind is blowing. So this is how the wind vane will help us to see the direction of the wind from where it's blowing. Then we also have what is called as a weathercock. See, it's basically a cock here. See here? Weathercock, see? Now this also will help us to know where the wind is blowing from. See again, when the wind blows, see the back portion of this cock is more compared to the head. So more pressure is applied here. When more pressure is applied here, this cock will turn towards me. Which indicates that the wind is blowing from this side. So therefore, if you look at the head of the cock where it's facing, it is from there that the wind is blowing. If the head is facing towards north, the wind is blowing from the northern side. If the head is facing towards east, the wind is blowing from the eastern side. If the head is facing towards the south, it is from the southern side that the wind is blowing. So this is another instrument which measures which shows us the direction from where the wind is blowing. Then we have the last one, that is windsock. This is normally found in the aerodromes or in the helipads. See, this is called as a windsock. You can see the cloth. The mouth is bigger than the tail, so more air will go inside it, whereby inflating it, and less air comes out. So this cloth that has been stitched into a circular form will basically bloat up, will inflate, and there will be air inside. So we know that whichever side this mouth is facing to, it is from there that the wind is blowing. If the mouth is facing from the western side, it is from the west that the wind is blowing. See, if it turns this side, and if the mouth is facing towards the eastern side, it is from the eastern side that the wind is blowing. So this way also we come to know the direction of the wind. So these are the instruments that basically helps us to see the direction of the wind. Then we also have an instrument which measures the speed of the wind. I told you the anemometer. Anemometer is basically, see, if you see here, see, like this. So what happens is, when the wind blows, pushes this cup, it's like a ball cut into two. When you cut a ball into two, see, and therefore that type of feature, object is basically fitted here. It looks as if it's a ball that has been cut into two pieces. And therefore what happens, when the wind blows, the wind will go into this, and therefore it will apply pressure, and therefore it starts to rotate. This is joined to a wire down to a digital box which shows the speed of the wind in kilometers per hour. It also shows the wind in digital form in kilometers per hour, you can see. So this is basically an anemometer which shows us the speed, how to measure the speed of the wind. It is an instrument used to measure the speed of the wind. Okay. Now this is just a lesson which I had done in the previous class. Now we'll continue from today the local winds. Now we have done what are the permanent winds, the trade winds, the westerlies and the polar winds are the permanent winds. Then I told you what are the periodic winds which blow for a certain period in one direction for some time and in the opposite direction for the remaining period of time. Those are the periodic winds like the monsoon winds and the land and sea breeze. Now we have local winds. Local winds are basically the winds which blow in a small area for a short duration of time. So local winds are basically the winds which blow in a small area for a short duration of time. Now it may blow because of the particular shape of the land or basically because it's near to a water body, because of the difference in the air pressure, whereby the wind blows in that particular area. So those type of winds which blow in a small area for a short duration of time is called as a local wind. Now we have different local winds that blows over the for surface. For instance, we have the first one, that is the Catabolic winds. Catabolic winds. Now these winds basically blow from the mountain surface down to the valleys. See, they blow down this way. From the mountain surface, they blow down to the valleys. They can blow even at a speed of 160 kilometers per hour sometimes. The Catabolic winds. Catabolic winds are those winds which blow from the mountain surface down to the valleys. And sometimes the speed of the wind can reach to a speed of almost 160 kilometers per hour. That is the Catabolic winds. Now we have some cold winds as well as warm winds which blow. For instance, if you see the examples of some of the cold winds that blow, Mistral in southern France is an example. Mistral in southern France is an example of this type of wind. Then we have southerly busters which blows in Australia. Then we also have Bora which blows in Hungarian basin. These are the cold winds. Then we also have warm winds which blow, that is Chinook in Rocky Mountains, and then we have Fohn in Alps and Sundowner in Southern California. So these are some of the examples of the Catabolic winds. We have cold winds as well as warm winds which blow. But catabolic winds are those winds which blow from the mountains down to the valley. Then we also have other local winds. Like for instance, if we take example of India, we have the winds called as Kal Baisakhi, which takes place in the month of Baisakh, April, May. Okay, during that time what happens? A lot of thundering takes place, a lot of hailstones, thundering, heavy rainfall, a lot of disturbance in the atmosphere takes place, whereby the winds can be very strong and sometimes destroys property and damages such a lot of things, crops as well. That is the Kal Baisakhi, example of other local winds, which takes place in, say, in West Bengal and Assam. Then we also have the example of other local winds like Lu, which blows in the northern plains, like in Punjab, UP, Bihar and so on. In those areas the winds blow. That is another example of a local wind. Now let us go a little bit further towards the other wind, that is the variable winds. See, we did the different types of winds like the permanent winds, the periodic winds, the local winds, and now we come to the variable winds. Now the examples of variable winds are basically cyclones and anticyclones. And cyclones. Examples of variable winds are cyclones and anticyclones. Now they blow in a small area for a short duration of time again. These cyclones and anticyclones, or the variable winds, blow for a short duration in a small area as well. In a small area for a short duration. Now let's see what is a cyclone. Now in a cyclone what happens is, basically the center of the area will have a low pressure. See, and therefore what happens? Because the surrounding regions have high pressure, what happens? Winds from the surrounding will come towards the center, this way, at a very high speed. And when they come, this warm air that is there in the center is pushed up. As the warm air rises up, these cold winds come to occupy its space. And as these winds are pushed further up, what happens? It cools down, condensation takes place, and therefore a lot of heavy rainfall takes place. In cyclones we have a lot of rainfall, a lot of disturbance in the environment takes place. See? A lot of thundering, lightning, very strong winds blow, heavy rainfall, a lot of things are damaged. So therefore, that is how the cyclone takes place. It's because the center of the region has a low pressure and the surroundings have high pressure. So what happens is, the low pressure air starts to rise up. And as it rises up, the cool winds from the surrounding will rush to occupy its space. And when these warm air are pushed further up high into the sky, it cools down, condensation takes place, and heavy rainfall occurs. That is how cyclone takes place in the northern hemisphere. See, anti-clockwise northern hemisphere. And if you see a cyclone in the southern hemisphere, this is a low pressure, high pressure. See, clockwise in the southern hemisphere. That's how it takes place. See. So a cyclone basically takes place anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Now I told you, when a cyclone occurs, there's a lot of disturbance, heavy rainfall, strong winds, thundering, lightning takes place. But in case of anticyclones, it is just the opposite. It's just the opposite in the case of anticyclones. In anticyclone what happens? The center has a high pressure and the surrounding regions have low pressure. See? So what happens? The winds will blow outwards from high pressure area to a low pressure area. Always. We have to always keep in mind, wind always blows from a high pressure area to a low pressure area. That means from a cold place, wind always blows to a warmer region. So this is in case of anticyclones. See, in anticyclone the central part will have a high pressure and the surrounding regions, the water bodies, will have a low pressure. So what happens? From the center, winds will blow clockwise in the northern hemisphere. In terms of anticyclone, it is clockwise in the northern hemisphere. But in case of cyclones, it is anti-clockwise in the northern hemisphere. So we are talking right up now about the anticyclones. So what happens is, when the wind blows, in case of anticyclones, the winds will blow clockwise in the northern hemisphere. See? And as these winds blow, these winds are coming from a cold region, cold place, the air is cold. Therefore, there is no moisture, there is no rainfall, there is no thundering, there is no lightning. Therefore, it has a pleasant or a moderate weather condition. In terms of anticyclone, they basically experience a moderate weather condition. A clear sky without any heavy rainfall, without any rainfall or strong winds blowing. Because there is no moisture in this wind. This is in case of northern hemisphere. In southern hemisphere, see high pressure, low pressure. Now what happens in southern hemisphere? It blows anti-clockwise. See? So this is also an example of an anti-clockwise that takes place in the southern hemisphere. Same thing, I have told you. When anticyclones occur, what happens is there is basically no rainfall. It's very clear and it has a moderate weather condition. But in case we experience a cyclone, then what happens? When cyclone takes place, there's a lot of disturbance, heavy rainfall, a lot of moisture is there, a lot of disturbance, thundering, lightning is there. Because the warm air has a lot of moisture, therefore heavy rainfall is given out during a cyclone. But in an anticyclone, there's no rainfall at all. It's a more or less a pleasant weather condition. Okay. Now let us go a little bit further, dear students, and see what is the next one, that is humidity. Now what is humidity? Okay, what is humidity? Now humidity is the amount of water vapor present in the air at a given time and place. How much water vapor is there in the air at a particular place, at a particular time? That is termed as humidity. So once again I say, humidity is the amount of water vapor present in the air at a given time and place. It is measured by an instrument called the hygrometer. Hygrometer. It records by itself. It's recorded by an instrument called the hygrometer or the wet and dry bulb thermometer. See, humidity is the amount of water vapor present in the air at a given time and place. It is measured by an instrument called the hygrometer or the wet and dry bulb thermometer. Now, to measure humidity, we require a scale. So the scales used to record humidity is basically grams per cubic meter and also percentage. So this is the scale that is required, used to measure humidity. It is the amount of water vapor present in the air. It is measured by an instrument called the hygrometer or the wet and dry bulb thermometer, and the instrument and the scale that is used to record humidity is grams per cubic meter or percentage. Now, humidity is of two types. We measure two types. One is absolute humidity, and the other one is relative humidity. We have two types of humidity. One is absolute humidity and the other one is relative humidity. What is absolute humidity? Absolute humidity is the amount of water vapor present in the air at a given time and place. If I measure the humidity right now, I am measuring the absolute humidity. I am measuring the humidity right now. So absolute humidity means the amount of water vapor present in the air at a given time and place right now. If I measure the humidity right now, I am measuring the absolute humidity. But what is relative humidity? Relative humidity is the difference between the amount of water vapor present in the air and the actual amount of water vapor the air can hold at that temperature. That is called as relative humidity. Once again I repeat, relative humidity is the difference between the amount of water vapor present in the air and the actual amount of water vapor the air can hold at that temperature is termed as relative humidity. If right now the atmosphere has 50% of humidity, but the air has the capacity to hold 100%. So this difference of 50 to 100 is called as relative humidity. It is the difference between the amount of water vapor present in the air right now, 50%, and the actual amount of water vapor the air can hold at that temperature, that is 100%. That difference is called as relative humidity. Then we have a term here that is called as saturated air. What is saturated air? Saturated air means when the atmosphere has 100% of moisture. Saturated air means when the air has 100% of moisture and the air can hold no more water vapor. We say that the air is saturated. Enough water is there. 100% of water is there in the atmosphere. So we say that the air is saturated. Then dew point. What is dew point? Dew point is also the temperature at which the air gets saturated and it cannot hold any more water vapor is termed as dew point temperature. Dew point is when the air is saturated and the air cannot hold any more water vapor. When the air cannot hold any more water vapor, it is termed as dew point temperature. Now if the air cools down a little bit further, if it cools down further, then it may result to the formation of dew or frost. If the air cools down a little bit more, furthermore, then it results to the formation of dew or frost. So dew point is basically the temperature at which the air cannot hold any more water vapor. Then we go to what is evaporation. It's very simple. You must have done this in the previous class. It is when water rises up from all the water bodies. When water rises up in the form of gas, vapor, we say it is called as evaporation. When water turns from liquid to gas, it is called as evaporation. Now water evaporates from all the water bodies. Water evaporates from the lakes, from the rivers, even from the clothes that you dry outside in the terrace or outside in the sun. From there also water evaporates. That is called as evaporation, when water turns from liquid to gas. Then what is condensation? Condensation. As the water vapor evaporates, what happens? It goes higher and higher up, and after some it becomes very cold, and therefore droplets of water is formed. When these droplets of water is formed because of the cold temperature is called as condensation. When the water evaporates, it's in the form of gas. As this gas goes higher and higher, it gets colder and colder, and after some it gets very cold, whereby what happens? Condensation takes place. And therefore, this gas is turned into droplets of water. Condensation is the process whereby gas is converted into liquid. So therefore, this gas or this water vapor which is in the form of gas is turned into droplets of water, which is called as condensation. Then what happens after condensation is formed? What happens? Then after some time what happens? It results to the formation of clouds. Clouds are formed. Clouds are formed. See? And after some time when the clouds are formed, what happens when it reaches a near mountain? What happens? It is forced to give all its rainfall. It's forced to give all its water in the form of rainfall or in the form of snowfall if it's in a very cold place, or in the form of sleet or in the form of hailstones. This process is called as precipitation. Precipitation. See, when the water evaporates from the water bodies, it's in the form of gas. It's called as evaporation. As this gas goes higher and higher, higher and higher, because of the cold temperature, what happens? Condensation takes place, whereby gas is turned into droplets of water. These droplets of water need to float in the air, and therefore, in order to do so, they cling onto the dust particles. They cling onto the dust particles, and that's how they float. And when all these droplets of water come together, when all these dust particles come together, it results to the formation of clouds. More the water vapor, more the dust particles, and therefore the clouds will look dirtier in color, black in color, because there's plenty of dirt in it, plenty of water vapor in it. But if there's very less water vapor in the clouds, then what happens? The less dust is also very less, and therefore the cloud also looks very white in color. So more the water droplets, the more the dust particles, and therefore the darker the color of the clouds. And therefore after some time, as these clouds come towards the land, and as they are obstructed by a land, or a hill, or a plateau, what happens? They are forced to give all this water in the form of rainfall, or in the form of snowfall, or in the form of hailstones, or in the form of sleet, which is called as precipitation. Now sleet is basically a mixture of snow and water. When snow and water mixes together and comes down, it is called as sleet. So that is how precipitation takes place. Now let's see the different types of precipitation. Different types of precipitation. I just told you the different types of precipitation are rainfall, snowfall, hailstones and sleet. Now the types of rainfall. Types of rainfall. The first one we have is called the convectional rainfall. Convectional rainfall. It is also called as 4 o'clock rainfall, and it takes place in the afternoon because that is the time when it's very warm. It mostly takes place in the hot regions, humid regions, like the equatorial region. What happens is when the sun shines, the warm air is pushed up. And as the warm air goes further higher and higher and higher, what happens? Because of the cold temperature right high in the sky, what happens? Condensation takes place. And when condensation takes place, it results in the formation of droplets of water. And these droplets of water will ultimately result in the formation of clouds. See? Will ultimately result in the formation of clouds. In the very hot regions like the equatorial region, when the sun shines, the land gets heated and the warm air starts to rise up. And as the warm air rises up very high up into the sky, what happens? Condensation takes place. And as condensation takes place, what happens? It turns into droplets of water. These droplets of water cling onto the dust particles to form clouds. And when they are still pushed further up, because of the continuous warm air coming, what happens? They ultimately are forced to give all its water in the form of rainfall. This type of rainfall which takes place is called as convectional rainfall. It is also called as 4 o'clock rainfall because normally it takes place in the afternoons. But most commonly it's very common in the hot equatorial regions. Convectional rainfall. Okay, that is the first type of rainfall. Then we have the second type of rainfall, that is called as the relief rainfall. Now this relief rainfall mainly takes place because of the obstruction of the winds. See, from the water bodies. See, water evaporates. And as they go higher and higher, their clouds are formed. These clouds go to the land surface. And as they go to the land surface, what happens? They are unable to cross the mountain. And in order to do so, they try to rise further up. But because of the presence of water vapor in it, heavy amount of water vapor in it, what happens? The clouds are forced to give all its water in the form of rainfall. So this is how we have the relief rainfall taking place. The relief rainfall mainly takes place because of the obstruction of the winds by the mountains or plateaus. When the winds are blocked, when the clouds are blocked by the mountains, the clouds are forced to give all its rainfall because it's too heavy. It cannot rise further and cross the mountain. So because it's so heavy with moisture, the clouds are forced to give all its rainfall, and therefore the water comes down in the form of rainfall. And the maximum amount of rainfall is received in the windward side. See, the side that faces, see, this side. The side that faces the ocean is called as the windward side. This is called as the windward side. This is the side where maximum rainfall occurs, because it's directly facing the winds. And after some time, when the clouds have given all its rainfall, it becomes very light and then it crosses the mountain. And therefore, as it crosses the mountain, this part gets very, very less amount of rainfall. Very less amount of rainfall. This side is also called as the rain shadow area. Rain shadow area. This part is also called as the rain shadow area. where they do not receive any much amount of rainfall. They receive rainfall but very less compared to the windward side. So the third type of rainfall that we are going to do right now is the cyclonic rainfall. Okay, cyclonic rainfall. Now, cyclonic rainfall again is basically when what happens is a low pressure center is formed. When a low pressure central region is formed, what happens is low pressure area is formed from the surroundings. From the surroundings, cold air comes to occupy space. When cold winds from the surrounding areas come to occupy the warm air, because warm air is there in the center. Because warm air is there in the central region, see, what happens is this warm air starts to rise up. This warm air starts to rise up. In a cyclone, basically a low pressure area is created in the center. In a cyclone, basically a low pressure area is created in the center. And therefore, this low pressure area which has warm air will start to rise up. And as it rises up, what happens is the cool winds from the surrounding regions come to occupy space. And then the warm air is pushed further and further up. And after some time it goes very high in the sky, it gets cooled down, condensation takes place, and then heavy rainfall occurs. That's how we have plenty of rainfall during a cyclone. A lot of disturbance, a lot of thundering, a lot of lightning, a lot of strong winds that blow. It's because a lot of torrential rainfall takes place in this type of rainfall. Okay, now the cyclones basically occur in both temperate and tropical regions. It is basically the meeting of cold and warm air. Cyclones is basically the meeting of cold and warm air. The place where the cold and warm air come and meet, it is called as a front. Therefore, this type of rainfall is also called as a frontal rainfall. Frontal rainfall. Now, as I was saying, it occurs both in the temperate and tropical regions. In the temperate regions, the rainfall is more, but is comparatively less. Okay, comparatively less as compared to the tropical regions. The rainfall lasts longer in the temperate regions. The temperate regions have a lot of rainfall, but not heavy rainfall. Milder rainfall compared to the tropical region, but they last for a longer duration. So this is the third type of rainfall, that is the cyclonic rainfall. And we have come to the end of this chapter, dear students. I hope you will go through the video and learn the lesson well. And whatever assignments are to be given to you, I'll give these assignments in your Teach Next section. You'll have to go to the assignment section in the Teach Next. And there, this video as well as the assignments will be uploaded, and you'll have to do your assignments accordingly. So till then, please do study well, be good, be safe, and take care of yourselves. Thank you so much.